Okay, we're going to cover how to figure out for this first graph the velocity, the acceleration, and the equation. For the first part, we're going to look at this graph. The whole idea for all these questions on this worksheet is for you to understand that the slope of x versus t is velocity. The slope for velocity versus time is acceleration. That's the whole idea. And then the last thing is that the area underneath the v versus t graph is going to be our displacement. That's the whole big idea. All right, so first question is, what is the velocity of this given graph? So all we're going to do is use our points. Some people are looking at rise of a run for short parts. Just take the whole thing. Okay, we have a point here. We have a point there. All right. So our x value, we have to get rise of a run, we need to get our rise, which is going to be, it goes from 20 to 70. All right. So our rise will be 70 minus 20. For our run, it goes from 80 to 0, or from 0 to 80. So 80 minus 0. So we have our rise of a run will be 50 divided by 80. So our slope is going to be 0.625. Again, it's asking for velocity. So the velocity is just the slope. The units for velocity are still meters per second. There you go. All right, next question saying is, what is the acceleration? If the slope is the velocity, like we just said, and if the slope doesn't change, that means the velocity doesn't change. If the velocity doesn't change, that means the acceleration is equal to 0. Again, if the velocity doesn't change, you have no acceleration. Because the slope doesn't change, the velocity doesn't change, the acceleration is 0. For the third question, what I'm saying is the right equation for final position. So what I really want to do is I want to take our equation for final position and plug in the values that we know, keeping the t in the equation. So the equation for the final position is our big ugly, which is right there. All right, so all we want to do now is plug in our values underneath. So for our xi, our initial position is 20. Our initial velocity is the velocity we just figured out, 0.625. And I'm just going to say times time, because I want to get basically the equation for the line. So anywhere along this line, I'll be able to figure out the position. Plus the 1/2 at squared. And we just figured out that a is 0. Okay? So really, anything times 0 we know is 0. So that whole thing is really going to be gone. So the equation for final position is really just 20 plus 0.625t, and that's it. Okay, thank you.